Before you guys start watching the video, make sure that you have your foldable and your notes out and ready to go. So you might want to hit pause, get that stuff out of your bags, and then hit play when you're ready. So where we're going to be writing in our foldable is we're going to open it up to the angle pairs flap. And this first set of notes we're going to be writing up in the top portion above the fold. Okay, so you can kind of see here in the picture where we're going to be writing and what we're going to be writing. So make sure again, you don't have to write super small, but you don't want to write so big that you can't fit everything. Okay, all right, here we go. So we're going to be talking about different types of angle pairs um, that exist in geometry, and we're going to be really using these pretty much for the rest of the school year. So make sure you pay close attention. You're drawing down all the diagrams, and then we can clarify anything we need to clarify in class tomorrow. So there's 4 sets of angle pairs that we are going to be taking a look at. So the first set, and you might have heard of this before, are supplementary angles. And I apologize about the writing on here. Sometimes it's not as neat when you're trying to do a video recording. So supplementary angles, basically these just sum to 180 degrees. So we're going to draw an example. We're going to draw one angle, and let's label it 120 degrees. So if I were to draw a second angle, like so, in order for the 2 angles to be supplementary, their measures would have to add to 180. So since this angle measure here is 120 degrees, that means that this angle has to be 60, because 120 plus 60 is going to give you the 180 degrees. Now you can also have 2 angles that are adjacent, meaning that they share kind of a ray here, that form a straight line, because we learned yesterday that a straight angle, such as a line, is equal to 180 degrees. So let's say that this was 100 degrees on the left side. That means that the angle on the right hand side would have to equal 80, because 100 plus 80 gives you back that 180 degrees. Now the second type of angle pair, again, you may have heard this term before, but we have complementary angles. So supplementary angles sum to 180, and complementary angles are going to sum to 90 degrees. So again, basically it's any 2 angles who, when you add them together, is going to give you 90 degrees. So if we were to draw one angle and we labeled it 30 degrees, that means if we draw a second angle, that second angle has to be 60 degrees, because 30 plus 60 gives you back the 90. I don't know what that little thing is that just showed up there. Okay, so another diagram that you might see that represents complementary angles is you may see something that looks like this, because we know that a right angle, which we learned yesterday, equals 90 degrees. And remember, you have to have that little box in there to denote that that is in fact 90 degrees. And we can kind of break this into 2 pieces, like so, by adding in a ray. So let's say that this portion of our angle was 50 degrees. That would mean that this one would have to be 40, because the 50 plus 40 sums to 90 degrees. Okay, now these next 2 angle pairs might be new for you. So the first one that we're going to talk about is a linear pair of angles. Now, a linear pair of angles basically are 2 angles that form a line. So what we're going to write, we're going to say that it's two adjacent angles that form a line. And since they form a line, that means that they're also going to add to 180 degrees. So we've got our line, we have our ray that's forming the two adjacent angles. So we're just going to label this angle angle 1 and this angle angle 2. So basically, since these are a linear pair because together they form this straight line here, we know that the measure of angle 1 plus the measure of angle 2 is equal to 180 degrees. And we're just kind of making a more general statement, whereas up here we actually put in angle values. Now, the difference between a linear pair and supplementary angles is a linear pair has to form a line. It absolutely has to form that line. Whereas supplementary angles just have to add to 180 degrees, but they don't necessarily have to be connected. They can be, but they don't have to be. A linear pair, the two angles have to be connected, forming a straight line. Now, the last angle pair we call vertical angles. Now, vertical angles are formed by two intersecting lines. And again, I apologize for the writing in this video. They are located across from each other and then most importantly, they are congruent to each other, which remember that means that they're going to have the same angle measure. So the first thing we need to do in order to sketch a pair of vertical angles is we need to draw two intersecting lines. Ooh, hopefully yours is a little bit straighter than mine was. So there's our two intersecting lines. Now let's label the four angles, because four angles are formed when we have those two lines that intersect. So we're labeling 1, 2, 3, 4. Now vertical angles are located across from each other. They are not adjacent, meaning they're not next to each other. So if we're looking at angle 1, the angle that is across from angle 1 is angle 3. So angle 1 and angle 3 are going to be vertical angles, which means that they are congruent to one another. So we can say that angle 1 is congruent to angle 3 because they're vertical angles. Now if we look at angle 2 is across from angle 4, which means that 2 and 4 are going to be vertical angles. So angle 2 is going to be congruent to angle 4. So those are the four different types of angle pairs that we're going to focus on for this unit, but as I said, we're going to be kind of referring back to these from here on out. So we're now going to jump to the bottom part, and we're going to put in two examples to kind of help you guys along with setting up equations to solve for missing pieces in these geometric diagrams. So we're now shifting to the bottom portion of our foldable. Okay, so we just wrote up here. Now we're going to be writing the examples down below. And you guys feel free to pause at any time so that you can catch up. All right, so when you are given a diagram relating to some of the angle pairs that we just discussed, There's a kind of a series of questions you should ask yourself to kind of help yourself along in setting up an equation to solve for the variable. The first thing that you want to ask yourself, excuse me, is, ooh, I don't know what that is, guys. Ignore that. Is what type of angle pair is drawn in the diagram? Okay, so do you have supplementary angles? Do you have a linear pair? Do you have vertical angles? That's the first thing that you want to ask yourself. Then from there, you should say, well, does that mean I'm going to sum my angles to 180 degrees? Or am I going to set them equal to each other? And we're going to set them equal to each other if they're congruent. Then from there, you can set up your equation and solve for your variable. Now the last piece, and we kind of talked about this, I think, on maybe Friday, Thursday or Friday, that you always have to check to see if you need to substitute the value of your variable back into the problem. Okay, so this step you're not always going to need to do, but you should always check. Substitute. You should always check to see if you need to go back and substitute that variable back in. All right, so let's take a look at example number 1. So we've got a nice little diagram here. You guys, again, pause so that you can give yourself time to draw the diagram. But the first thing that you want to ask yourself is, what type of angle pair do I have here? Okay, so now if we look at this diagram, we have two angles. We have angle ABC and we have angle CBD. Okay, if we go back to our angle pairs, what does that look like to you? Which diagram? And it looks like this diagram here. It looks like a set of linear angles here, linear pair. So that's what we've got going on here. We've got a linear pair. So what type of angle pair? Linear. So then what does that mean? Go to question 2. Does that mean we're going to sum our angles to 180 degrees, or are we going to set them equal to each other? So if we go back to a linear pair, it says a linear pair adds to 180. Measure of angle 1, I don't know what this is that keeps popping up, you guys, I'm sorry. The measure of angle 1 plus the measure of angle 2 equals 180. So if we sum those two angles together, it should equal 180. So that's what we're going to do. We need to sum our angles to 180 degrees. So now for step 3, we can set up our equation and solve for the variable. So we know that if we add our two angles together, that they're going to equal 180. So now from here, we're just going to go through and solve. So this is going to give us 5x plus 90 equals 180. If we subtract 90 from both sides, we get 5x equals 90. Divide both sides by 5, and we get x equals 18. So now step 4 is just to substitute if needed. Since this problem is just asking us to find the value of x, and we've done that, we don't actually need to do step 4. Okay? All right, so moving on to the second example, and again, you guys might want to pause and give yourself a minute to draw the diagram before continuing. All right, so taking a look at this diagram, again, following those 4 questions or those 4 steps up at the top, the first thing we want to identify is what type of angle pair do we have here, okay? So in order to determine what type of angle pair we have, we want to look back at the different types of angle pairs that we have up at the top of our foldable. So that diagram, for example 2, looks like this one. And the reason why is because we have 2 intersecting lines. So when we have 2 intersecting lines, we want to check to see if we have vertical angles. And remember, vertical angles have to be located across from each other. So going back to our example, we do have 2 intersecting lines, and these 2 angles are located across from each other. So we have vertical angles. Now the second question is, do these angles sum to 180 degrees, or are they equal to each other? Are they congruent? So looking back at what vertical angles are, it says that they are congruent. So since they're congruent, that means we're going to set them equal to each other. Sorry, I keep flipping back and forth here. All right, so that means that our angles are congruent. So we're going to set equal to each other. All right, so step 3 then is setting up that equation and solving. So we're going to take 3x plus 20 and set it equal to x plus 65. So now we're going to subtract x from both sides. We have 2x plus 20 equals 65. Subtract 20. We get 2x equals 45. And then divide by 2, and we get x equals 22.5. Now step 4 that we have listed in our foldable is to substitute if needed. So in this case, we're asked to find the measure of angle ABE. So that means we do need to substitute this back in. So ABE, if we start at A, go to B, and then over to E, we're looking at this angle here, okay, this guy. So the expression that's being used to represent angle ABE is 3x plus 20. So the measure of angle ABE is being represented by 3x plus 20. So we're just going to substitute in our 22.5 for x. So that's going to give us 67.5 plus 20, and then 87.5. So that is going to be the measure of angle ABE. Okay, once you guys have that in your foldable, go ahead and take out your notes, whether it's a continuation of yesterday's or you need to get a new page, whatever you need to do, but we're going to go through a couple more examples, and these should go into your notes. I'm going to change the color here just so we can kind of differentiate between the different problems here. Okay, so here is our first problem. And it says list which angles are linear pairs or vertical angles. Now we know that linear pairs and vertical angles are just made up of 2 angles, not 3. Okay? A lot of times what people will say for this problem is they'll look at this line here and they'll say that, oh, angles 1, 2, and 3 are linear because all together they form a straight line. but a pair just means two. So 1, 2, and 3 cannot be a linear pair because it's three angles and not two. If we look though here at this line, angle 1 and angle 5 together actually form this blue line here. So that means that angle 1 and angle 5 are going to be a linear pair. Okay? So linear pair, we've got angle 1 and angle 5. Okay. So let's erase that. Now for vertical angles, we know that we need to have two intersecting lines. Okay? So if we look at kind of this guy here, this is just a ray. Okay? It's not a line. So we can't include this when we're looking for vertical angles. Our two intersecting lines are this line here and then this line here. Those are the two that are actually intersecting. Okay? So now, if we look at this portion of the line in here, this forms angle 1 together. Now these part of the lines here and here form angle 4. So since angle 1 and angle 4 are formed from the intersection of those lines, they will be vertical angles. So angle 1 and angle 4. Okay. Moving on to number 2. So again, pause the video, you guys, if you need a second to copy this down in your notes. Okay. So what we want to do is we want to find x and the angle measures. So angle 3, we are using 3x plus 95 to represent that angle measure. And then here we're using 12x minus 20. So running through those 4 questions from your notes, what type of angle pair do we have? Since these guys are adjacent and they are forming a line, that means that this is a, whoops, sorry about that. That means that this is a linear pair. So since it's linear, ask yourself, does that mean that they're going to add together to 180, or are they going to be equal to each other? Well, since they form a line and a line equals 180, that means that these guys are going to sum to 180 degrees. So then we can set up our equation by adding the two expressions together and setting it equal to 180. So that's going to give us 15x plus 75 equals 180. If we subtract, I'm going to kind of run out of room here, guys. If we subtract 75 from 180, we get 105, which means then that x is going to equal 7. So x is going to equal 7. So we've got that, but then it also says to find the angle measures. Okay, so angle 3 then, what we have to do, that's step 4, is we have to substitute in. So for angle 3, we're going to have 3 times 7 plus 95. So that's going to give us 21 plus 95. And again, I'm sorry, I'm kind of running out of room here, guys. Oh. And the writing's kind of bad. But that's going to give us 116 degrees. So angle 3 is going to be equal to 116 degrees. Now angle 4, again, you can just substitute in that 7, or, oh my gosh, I don't know what's going on here, you guys. Hold on. So angle 4, we've got 12 times 7 minus 20. So this is going to give us 84 minus 20. So angle 4 is going to be equal to 64 degrees. And you can check to see if you did your math right, because the measure of angle 3 and the measure of angle 4 should add up to 180 since this is a linear pair. Okay? All right, last example, and remember you can pause at any time. All right, so it says given the diagram, find the value of y, then find the measure of all 4 angles. So now here, even though this diagram has 2 intersecting lines, so we might think that we're looking for vertical angles here. If you look at the 2 expressions, they're not located across from each other. They're located right next to each other. So y minus 12 is representing this angle, and 3y minus 8 is actually representing this angle here. So together, these 2 expressions are actually forming a straight line. So the type of angle pair that we have is we have a linear pair again. Even though the diagram might make you think that we've got vertical angles, it's actually a linear pair. So that means that they're going to sum to 180. So when we set up our equation, we're going to take y minus 12 plus 3y minus 8 and set it equal to 180 degrees. So that's going to give us 4y minus 20 equals 180. If we add 20 to both sides, we get 200. So y is going to equal 50. Then it says to find the measure of all 4 angles. So we have to take that y equals 50 and we need to substitute it in. So this angle up here, if we take y minus 12 and we substitute in 50, so 50 minus 12, what is that going to end up giving us? That's going to give us 38 degrees. So this angle in here is going to be 38 degrees. Okay. Now this angle down here, when we substitute in our 50 for y, we're going to get 150 minus 8, which is going to give us 142 degrees. So this angle down here is going to give us 142. So now how can we find the measure of the other angles? There's a couple ways you can do it. One way is by actually using vertical angles. So this angle here, this 38 degrees, is opposite or across from this angle here, because remember, we have 2 intersecting lines, so we should have vertical angles, okay? So since this angle here is 38 degrees, that means that this angle here is also going to be 38 degrees. Now since this angle down here is 142, that means that the angle across from it, which is this one, is also going to be 142 degrees. Okay, once you guys have gone through and you have your foldables filled out and you have these 3 examples in your notes, you can go ahead and get onto Class Zone and you can get going on the homework, and hopefully you'll have time in class to get the majority of this done. And I will see you tomorrow.